Well, this is one of those places where I don't dare coming without a shirt. And the very elegance and beauty of the room is a perfect backdrop to talk about visualization and exploratory data analysis. So in Python, there's really two main libraries for graphic visualization or representation. One is Matplotlib, probably the oldest of the two, and the other one is Seaborn, which is a statistical visualization libraries. And the combination of both of these libraries is really a powerful tool because you can do very simple graphics, quick and dirty, just looking at the data. Or you can do more sophisticated graphic, changing, for instance, the colors. We can do colorful graph charts, bar charts, for instance. Or even you can plot, and that's extremely useful for geoscientists or any scientists working with Earth's data. You can plot data on top of a map. And so you can then have a visual representation of where your data is. And we'll have a chance to play with these concepts later in this class. And not only can you do simple plots, but also visualization is a key component of EDA, the Exploratory Data Analysis, which is a key component of any data science machine learning project. It's when you start basically exploring your data through graph and visualization to find trends and to identify potential good candidates for training of machine learning algorithms, for instance. And EDA typically will include some component of plotting data against each other to find covariance and distribution of your data sets. And you can even do plots that have multiple subplots, so that are basically combined graphics plot. And this is, again, very powerful because it allows you to tell your story through graphics. So let's focus a little bit on these plot with subplot because that can be somewhat confusing. And I want to introduce these notions of figure and subplot and how we actually use them, how we use the different axes. So if you use Matplotlib, typically you will call it in your code PLT. You can call this subplot routine here. And what subplot returns is a tuple of two things. One is the figure, and the other one are the axes, and that's a list of the different axes. Now the term axes might be a little bit confusing, but really what it refers to is the different subplot within your main plot. So let's look at the details of that. So the figure is essentially the whole canvas of your plot. That's where everything will be drawn. The axes represent the subplot. Now in this case, I've created a subplot of two rows. The first number represents the rows, and two columns. Now graphically this would be represented like this. So if I take my figure, the subplots I've created can be represented graphically as rows and columns. So I have row 0, row 1, column 0, column 1. And every one of these subplots can essentially be called by its coordinates. So graphically again, this would come to axis 0, 0 on the upper left corner, axis 0, 1 in the upper right corner, axis 1, 0 in the lower left corner, and axis 1, 1 on the lower right corner. So you can see that graphically this is a matrix of different plots. And obviously you can do much more complex plot. You can have many more axes, and some of the axes can be combined as well. So it can get more complicated than this. But the principle is fairly simple. Now that we have coordinates for each one of these axes, we can start to plot graphs on them by calling each axis separately. So in concrete terms, in terms of coding, if I wanted to create 4 histograms in these axes, what I would do is I would call them by their coordinate and then assign a histogram to them. So it would look something like this. For axis 0, we call it an histogram, 0, 1, another histogram, 1, 0, and 1, 1, same thing. And now I obtain 4 histogram on this figure. And if I plot this figure, I obtain something like this. So I've left here the figure and the axes so you can understand which figure corresponds to which axis. And I think this is really a powerful thing about Matplotlib and Seaborn, is that you can compose the different coding elements to produce a very powerful graphic representation of your data. And remember, a picture is worth 1,000 words, so you can tell your data story through visualization.